Okay, our session is being recorded as always. Welcome to week 5, 12-week course, so we're not quite to the halfway point. I know that there's a bunch of very well done assignments waiting for me to look at in the Leo website. As I may have mentioned, I'm not sure if I did or not, but I'm at a conference this week, presenting at a conference and attending a conference. For people who teach online and they wanted to hear about analytics. So I'm tied up a little bit, but I will get the grading done. It might be by the weekend before I can get to final grading and get you your feedback, but that will happen. So draw a deep breath, rest up briefly, and then we move on. Now we're moving into sort of the second chunk of our course where we're going to use some end-user analytics tools and build some models. I know you've done a little bit of this with RapidMiner and a little bit of other things in 600, so this will be a little different experience, different piece of software. Make sure that you mute, let me get people muted as they come into the classroom so we don't have any feedback. There we go. Okay, we've got some tools in this course that I think are great. You know, as I told you before, one of the reasons or the way in which I choose things I want to use in the classroom, and I hope you would agree with this, is I choose things that are, first of all, user-friendly. Decisions first. Maybe it wasn't as user-friendly as you'd like it to be, but it's user-friendly considering you don't have to do any programming as such. And, of course, once you get used to the interface, which is new to everybody, there it is. Well, same thing will hold for prediction. Same thing will hold for big ML. Second criterion I use is, of course, I want something that's relatively easy or used in the real world a little bit. Okay, well, Prediction has some pretty big backers behind it, as you'll see in a moment, as does big ML, as does clients, as does decisions first. It has the third criterion would be it has to be affordable. And fourth, it has to be something that makes sense to use in a classroom where you can learn it and move on relatively quickly. So I like to pick software. Now, what we're focusing on here is it says these are some end-user tools. When you get to Data610, where you do some really heavy lifting using SAS Enterprise Miner, we'll be using much larger data sets. You'll be using much more complex and powerful tools that can do a lot more things. But these are quite adequate for a lot of analytics. You know, we're going to have a world of data scientists who want to use some heavy-end tools. We're going to have a lot of other people, whether they're business analysts or just or just regular functional area people. I shouldn't say plain old, they're very valuable people. They may want to do some of their own analytics, and so some of these tools are quite useful for that. They're very good. They work well, and you'll see that as we get to use them. Okay, having said that as a precursor, let's move on. So what I'm going to talk about tonight is, in fact, that I'm going to talk about this software package that we're embarking on for a few weeks called Prediction. I like it a lot. Okay, now don't let that prejudice you. You need to be honest in what you do and don't like. The company, as is all the companies that we deal with, are very anxious to have feedback, constructive feedback, pro or con. And so we'll say a little bit about that tonight. Of course, the key here, again, is you spending time with it, as always. I can't give you a lecture that will make you knowledgeable about it. You have to spend time with it. You have to try it. You have to practice. You have to experiment. You know, there's a fog factor that rolls in early. Anytime you're learning any new software, it's been my experience, including myself. When I'm learning new software, I scratch my head and say, what in the world is happening here? And then hopefully as you begin to master it and ask questions and hear more about it and read more about it and watch the tutorials, the fog begins to lift, and all of a sudden you feel like, hey, that's not too bad. So that's the process that seems to always occur for me. How long that fog stays in, that's a matter of opinion. So I'm going to say something about that, and I'm going to talk about weeks 5 and 6. Again, this is your brief respite, and you shouldn't take too long of a respite before you get into this software. So this is the week to get into this. All right. So we're going to start this segment. We're going to use several end-user analytical tools over the next few weeks. Prediction being the main one, weeks 5 and on. Okay, that's the primary analytical software for this course. Walkthroughs and tutorials, we'll talk about that. I will demonstrate in week 7, excuse me, while you're still working on your second assignment, I will demonstrate a package from Palisade called Evolver. Now, why is that in there? You're not going to use it. You could. It's free for 30 days. You could use it, but you're not going to, most likely. It has some very powerful tools. It has a neural network tool. It has a ranking tool and other algorithms. It was one that was considered. It's probably better suited for an MBA program in the sense that it does a lot of risk analysis versus pure what we call analytics. But it does have one module, Evolver, excuse me, which does something very unique. Does evolutionary algorithms, and that's if you recall the chart, that's up there at the optimization end of the analytics world. So we thought, well, we needed to show something about genetic algorithms somewhere in the program, and so I said, I've taught that before in other courses. I'll show a demonstration. It's pretty impressive. For the class of problems that it deals, it is extremely impressive. But don't worry about that. That's more of a demo while you're working on yours. And then, of course, we get into big ML, big machine learning, when we do weeks 9 and 10. So you don't need to worry about any of that now. What you need to be concerned with, or not concerned with, but spending your time with, of course, is learning prediction. Small company, founded in 2009, headquartered in California. You will notice has some pretty good investors. Accenture dropped, I think, $60 million on the company. They're the backers. Software AG, Accenture, GE, and EMC have all put money into this company, and they're impressed so far with the results. A very nice software package that looks like it's going to fill a niche, quite a good niche. Again, not up there necessarily with something like SAS or SPSS, but a good niche. They have people there who built it with PhDs in various areas. And of course, again, here's some of their partners, including Microsoft. These are partners. These are people who basically funded the venture capitalists, I guess you could call them. Accenture and all they're all involved. And here are some of their customers. And again, these are not chopped liver, people like Cisco and GE and so forth, pretty well known. Some of these other companies not as well known, but certainly there. USAA and so forth. So we have lots of potential here. Will they make it in the long run? Gee, I hope so, because I like the product a lot, but there are competitors, as you know. So let's get into it a little bit, talk about some of the key features. One key feature, of course, this is an Excel add-in. So you need to have Excel. It's going to be Excel add-in. The other nice thing about it is all of the computational heavy lifting is done in the cloud on the Prediction servers. So you have basically a small client software installed on yours, but all the heavy lifting is done up on the Prediction servers, and of course free for us to use in this course. Very nice, and very, very, so far the uptime, the reliability has not been a problem. We haven't had any outages or serious problems that would minimize the ability. As you know, when you're running in the cloud, of course, you want to have the thing available to you, and you want to have good bandwidth so that you don't have to wait forever to make the loops back and forth from the cloud. Now, Prediction Insight, that's the name of the software, is actually two programs. There's a module called Prediction Insight Now, and another module called Prediction Insight Analytics. They're both part of the same program, but they're different ribbons, if you will, on the Excel, and I'll show you a little picture of that in a minute. Prediction Insight Now is the piece of the software you would use first to get a quick look at your data set. Get some visualizations, start examining your data, cleaning your data, maybe doing some transformations, putting in something for missing values and so forth, depending on the kind of model you're building. We'll talk more about the tools and techniques next week when we talk about a little bit about decision trees and regression and neural networks and so forth. Some of the models, like decision tree, you don't have to do much with. Other models you probably want to do a little bit with. But most of that work is done in the Insight Now. The heavy lifting, so to speak, of building the actual analytics is in the thing called Prediction Insight Analytics. Together, they comprise Prediction Insight. Okay, that's where the models are built, and that's where the sensitivity analysis tools reside. Again, you'll get very comfortable with this the more you use it. This is a magic quadrant, as some of you know from Gartner. We've seen some of these before. Down here is prediction. Okay, right there. Now, again, not as high up as perhaps RapidMiner, and certainly not up here with SAS, which we use in Data610. but moving. If you read the whole report, you will see that prediction has moved up dramatically and is continuing to move up. And there's some very good indications that it will move into this top right quadrant soon. Again, they seem to release a new release about every 6 to 8 months. The last release came right in the middle of our spring course, which caused a little angst. Didn't change the software night and day, but added a few tweaks, changed a few things. Of course, that meant we had to jump on the learning curve quickly. So right now, there will be no introductions during this summer session that I'm aware of. So we're using version 4. A little bit of from that same report, the Gartner Group, talking about prediction. There's a couple of key things in here. It's focus. Again, this is right out of the Gartner report, providing targeted applications for different cases and industries. Healthcare, life sciences. This one I, of course, am especially interested in, the Internet of Things. When we start putting tens or hundreds of billions of sensors in things, all of which are capturing and relaying information, something's got to analyze that and in many cases take action on that. It's not going to be people. It's too slow. And predictive maintenance. I'll talk about a case study on predictive maintenance here in just a minute. On top of that, together with its investor and partner Accenture, heavy emphasis on its go-to market strategy, deployment of models, blah, 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 blah. The other thing that's really key here is the deployment. They're going to deploy it on BI platforms, business applications, workflows, mobile devices, and portals. Mobile devices and portals. We're going to see, when we talk a little bit about trends later in the course, we're going to see that one of the big trends, of course, is to get where you can do most of the heavy analytical modeling kinds of things on your mobile device, whether it's a smartphone or a tablet, because that's what people carry with them. Strengths. Prediction highly in terms of overall satisfaction. Vision for ease of deployment in different environments. I mentioned that, especially remote devices. This will become significant as the IoT, Internet of Things, expands. Positive customer feedback and its vision, roadmap, knowledge set. Cons. Okay, trying to do too much. That might be. Initial deployment can be complex. Well, hopefully you've been able to get yours installed and working. And low market visibility, obviously. And, small companies have trouble getting market visibility, don't they? I'm pleased that we're able to use it. Okay, let's talk about getting started. Enough about that. Enough little infomercial. Let's talk about getting started. What are you going to do? Well, once you have it installed and open up Excel, you're going to see 2 new tabs over here. Insight Analytics, Insight Now. Again, they'll both show up, assuming things go well. You'll be able to use those. So when you click on, from Excel, if you click on either one of these, you get another little sub-menu, and on that sub-menu will be a prediction tab. Click on that, click on Getting Started, and you get this screen right here. Until you're very comfortable, I think you'd be better off to just let this screen check. There's a little box down here that says show this every time you start up. I think you'd be better off to just keep showing that for a while. A couple of reasons. You can get to the tutorials very quickly. You can get to the sample data files and take a look very quickly. And you can get to the help system a little bit easier than going the normal way. So this will show up again. Click on one of these, then there's another row of tabs that shows up. Click on the prediction tab, which will be far left. Click on Getting Started, and here it comes. All right, so let's take a look at some of these pieces that are in here, because this is what you're going to get used to. The first thing you'll want to do is go look at these tutorials, and there are several of them. What's new, and I put them sort of in the order I would think you'd want to look at them. Excuse me. You want to look at what's new, although it's a review of what's in there as well as what's new. And again, unless the company will help you with the installation process if you struggle, but you should be able to get that installed okay. How to connect to your data. There's several ways you can use data, from SQL, pivot files, or spreadsheets. Most of us use our data from spreadsheets for this course. Preparing and exploring your data. Some of that you do in the Excel spreadsheet. Some of it you can do at sort of their website. They sort of split that up. So you want to watch this video and take a look for yourself. Then the key things: overview of the Insight Now ribbon, overview of the Insight Analytics ribbon. Again, two different ribbons, part of the same program. They'll both be there. Working with multiple data sources might not be something that's that important to you in this course. Most of us just pull up one data set at a time and do our assignments with that. If you want to use multiple data sources, this video will tell you how. And then, of course, the key one, the last one, after you're comfortable with these, actually building a model. Okay? And they're pretty well done. This is the link. Sorry, it's grayed out. It's probably because I clicked on it, but you'll find it. Again, right from that main site. Okay? I see a question. What level of statistical knowledge do you need to know to use this software? I would say 0 to use it. Now, this begs a bigger question. It's a good question, by the way. It begs a bigger question. You'll hear me repeat this same mantra many times because you'll probably have me for another course. I built and teach the 640 course, so I'm probably going to run into most of you in that course. The mantra is this: what has happened in the world of analytics is that the drudgery, the tediousness of actually doing the calculations is gone. And more programs are automating more and more things. They're automating certainly they're automating doing the tedious calculations to build a regression model, a neural network model, a decision tree model, a logistic regression model, whatever. So you push a button and you got a model. Now I go back to the old days when I had to build these things by hand. In my regression course in my doctoral program, I literally, and I'm not exaggerating, took 7-8 hours to build a regression model, one model, on a problem probably 1/10 the size of any data set you're going to use. And that's because we didn't have personal computers in the late 70s, early 80s when I was in my doctoral program. So we did everything on calculators and wrote it down, and then more calculators and wrote it down. We didn't have software. We didn't have anything that would do those kinds of tediousness. So that's gone. The second thing that's gone or going is a lot of the preparation of the data, whether it's transforming it, imputing missing values, smoothing it out, and so forth. A lot of that's being automated. And more of that probably is automated in high-end products like SaaS than in the lower-end end-user products. But more and more it's being automated. So more and more it's becoming where you can push a button and have a model. Now, that means the table has flipped a little bit. Here's what you have to be good at now. And this ties to the question that was asked. You don't have to know anything about statistics to build that model. However, when you when you compare multiple models, let's say because it's so easy to build a model that you build 8 or 10, you tweak a few things and try a different model, or you try different algorithms. You may build a decision tree, a neural network, a regression tree, a support vector machine, all on the same set of data to see which one wins, because as you'll find out when we talk next week, there is no way to predict which technique will give you the most accurate model. So there's one thing you have to do is build multiple models and then be cognizant enough of the accuracy kinds of measures we have, which again we'll talk about next week, to be able to sort them out, say which one is actually the better model. Then the other thing you have to be able to do is explain the models to the people you got to sell it to. Remember that third chunk of Davenport's book? It's okay to frame it and it's okay to build it, but can you sell it? Can you convince people that what you did was right and what you did makes sense and how you did it? And there you have to be able to translate complex, somewhat complex techniques. I mean, regression, neural nets, decision trees to a lesser extent are all pretty complicated techniques. You have to be able to translate that in English. So we will come back to that question, because part of what we do more of in this program than ever before you would have done in a quantitative course like this is focus on the understanding of the techniques. What's going on behind the scenes in layman's terms so that you can articulate that. And you do have to understand some of the statistics, but you don't have to know any of them to push the button and get the model. That makes it dangerous in a sense, doesn't it? It also makes it intriguing, because I think it opens up the world of analytics to more people, I was extremely good at ciphering. I can do square roots by hand. I can add, subtract, multiply, and divide rather quickly. I'm very good at that. That is a needless and useless skill in today's society. What is the better skill is being able to, as I said, frame the problem, build the models, understand what you've done, trade off many of the features of the models, try different things, compare the models, explain and sell the models. And all of that will become clear to you. But you do have to be able to build the models. So we're going to learn how to build the models. We'll focus in the third of the course, or the last few weeks at least, on, okay, how are you going to explain some of these things? So good question. I'm blown away now. Again, I'm older than the rest of you, so I'm very much blown away by how quickly you can build a model in these software packages, because behind the scenes, I know what's going on. There's an awful lot going on, but it's going on rather quickly. We'll explain a little bit about that next week, what's going on behind the scenes. Okay, so one of the, so one of the things you want to start with are the tutorials. They're videos, fairly well done, good explanations. The other thing you might want to look at is some of the data sets that are out there. Again, from the main web page, remember this page here, you can click on this thing, samples. It'll take you to this page. It has more stuff than just these sample files. But these are some pretty good data sets, okay? And they're quite varied. The one that we see a lot of stuff done with, of course, is readmission to raw, because that's a nice, real, large, relatively modest size, but large for us data set. And you can see there's all kinds of other things in here. So when you come to building your models, these would be potential data sets you could use, although I would encourage you to look for others. There's also other resources at this same page. I didn't cut and paste all those on there. There's some technical info, white papers, etc., about the program, which are all very worthwhile to read if you have the time. But you might want to look at some of these. Some of these are fully built models. Some of them are just data sets. Okay. Then there's the help screen, of course. All right, so let's move on now to Insight Now. Remember, that's one of the two pieces that constitute the Insight software. Insight Now, it's a very good visualization tool, a quick starter. When you click on the Insight Now button, tab rather, you will get this new, what we call a ribbon in Excel, okay, ribbon. So this is where you click Prediction and get that Getting Started tab. But okay, there's Prediction, analyze key influencers, detect categories, fill from example, forecast, boom, 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 boom. Okay, some management tasks over here. I like the Insight Now. Here are some walkthroughs just on Insight Now. Walk you through each of these little tabs, the buttons, if you will. However, there's one here that I favor above all the others. Okay, and it's this one. When you start to build a model, what do you have? Well, you have a bunch of data. Some of the data are, some of the variables in the data set are inputs, and some are answers, the output, the target, whatever you want to call that. So the inputs we call predictors, we call features, we call them inputs, we call them input variables, we call them lots of things. The answer, the thing you're trying to predict, we call the target, we call the output. It probably has other names. But one of the things that's real nice to do is to get a quick feel for which of those inputs is likely to show up in the final model as strongly related, correlated, if not causative, to the answer. Okay? And that's what this one does. Now, so if you bring your data set in, once you get it ready to go, and click Analyze Key Influencers, and this is a little walkthrough talking about how that works, here's what you get. Okay? This is, again, a screenshot right from this walkthrough, but it's on a data set where what you do first is saying, what are the things that you're trying to see the relationship to? And this was interest in buying. That was the variable. You know, which of these many inputs has a strong influence on a person's interest in buying? Because this is what I'm trying to do. I'm trying to predict which people are going to buy something. And so it went through and did a chi-square correlation one at a time, not in combination. And it came up with this nice chart. And the longer the bar, the stronger the influence. Longer the bar, the stronger the influence. And of course, it can be a positive influence or a negative influence. And this explains what it is. This is the name of the column that designates the input factor. So here are all the input factors. This is the value most strongly associated. Each of these input factors has many values it can take, right? Overall satisfaction, apparently you can rank something 1 through 5. And it says, well, if they give it a 3, that has a big thing there. The outcome of the target value that the factor predicts, it predicts strongly an outcome 5, which is one of the values for the outcome. The relative impact, that's the length of the bar. And then finally the confidence, a measure of how statistically significant that is. Okay, so that's nice. So right away you're thinking, oh, when I build my final model, I'm going to include these factors for sure, right? And I may leave some of these other things out. You don't want to have a model that has a zillion factors in it because, again, the more factors you have, the more cases or instances or occurrences you have to have in order to avoid, degrees of freedom and some other problems. And then the more missing values you could have if you have more factors, and the more transformations of variables you have to do if you have more factors. So you'd like to have an economical model. We'll talk about feature parsimony next week. Okay, you'd like to have an economical model. Now, when you first look at this, you think, hot dog, this thing is telling me that I need to include all of these things. Well, certainly these things that are got this check mark on confidence, whatever that means, you can read the details about that. I want to put those in the model for sure. These other things, well, they got reasonable length bars, but the confidence isn't very high and so forth. It's not that simple. If it were that simple, we'd have a 6 or 8 week course instead of a 12-week course. And here's why it's not that simple, as we will discuss more again next week. It sometimes turns out that combinations of factors that aren't significant as individuals make a strong combination influence. In other words, when you put together some of these low, short bar, non-significant factors, when you combine them and put them together in a model, they have a significant ability to impact the outcome of the target. So you say, well, what value is this? Well, this gives you an indication, nothing hard and fast. This gives you an indication of which variables you certainly want to think about first. Now, again, one of the values of having this very sophisticated, fast-working software, whether it's Predixion or SAS or SPSS or RapidMiner or any of them, is the ability to build multiple models. So what does that mean? Well, you may try one with these first 3 in it, see what you get. Again, accuracy measures will be discussed next week. You may try another one with maybe the first 2 and the 4th one, or you may create a dozen models. Why not? All you do is push a button once you set it up right. I say all you do. It's not quite that simple. But basically, you can create the models extremely quickly. Again, going back 20, 25 years ago, maybe even 15 years ago, that was not doable. You had to be very insightful and think long and hard, longer and harder about your problem because you really only had the wherewithal and the time to do probably one model because of the tremendous burden of the calculations. Now the calculations are trivial. They're behind the scenes and they're done in a twinkling of an eye. So the premise now is on, okay, let me think about how I want to combine some of these inputs. We'll get to that. Right now I'm just trying to show you what sort of some of the screens look like. Okay, so Insight now has other tabs and they do other things. They're fairly obvious. Detect categories, that would be good if you're going to build a clustering model or an association model, again, to be discussed later. Those are unsupervised kinds of things, just putting things that are likely to be grouped together. That's a good starting point. Building from example, I don't see a whole lot of value for that. Forecast, quick and dirty forecast. You say, here's what's happened the last 3 days. Tell me what's going to happen tomorrow. Highlighting exceptions, that might be useful. You'd like to know, when you look at your data, I probably should give this one a little more emphasis. You'd like to know which inputs have variables that are 6 sigma, 8 sigma, 10 sigma away from the mean, because I may want to lop those off. You know, if I'm looking at age and everybody's between age 35 and 45, and all of a sudden here's one over here who's age 150, that's probably a typo. I want to delete that. So you can highlight some of the exceptions. But the main thing I see, I really like this one because I like to look at that so you get a good quick feel for which variables might show up in the final model. Okay, then the analytics ribbon. If you click on Analytics tab, you're going to get a different ribbon. Okay, this is one that does the heavy lifting. And of course, there's some things here, new and open and view and share and so forth, sort of some getting ready to build models pieces. Then there's the building of the models right here. And then there's using the models or applying the models. You can validate them and you can predict with them. You know, want to do something with it once you get it right. And then there's some housekeeping stuff over here. Most of the focus, of course, is spent on these ones in the middle. Classify, estimate, segment, associate, forecast. Not too much the last two. Applying script and doing some component analysis. But the first four, certainly, maybe even the fifth one, are really the heavy lifting. As again, we'll discuss a lot more detail, but you know, we have certain models where we call them supervised models because we give the model the inputs that we think are the appropriate ones, and we give it the output that occurred with each of those cases. Those are called supervised models because we're giving the software, the machine learning software, the inputs and the answer and saying, can you figure out how they match up? And then we're going to use that in the future on some ones where we don't have the answers, right? If it works well. So in those, you have to have a target that's identified, an output. And the main ones there are classify, estimate, and forecast in this software. And each of these has several techniques under it. So these are just the main sort of titles, if you will. Then we have some unsupervised model techniques where we don't have a target. We just have data and we want to find out something very interesting and insightful about it. What do? Well, segment. Segment groups things. Says, you know, of your whole data set, these 15 are sort of the same or have a lot of same features. These are sort of your guys and gals who tend to buy a lot. These are the guys and gals who buy a little bit. These are the guys and gals, again, characteristics of the guys and gals who don't buy much. You know, but we don't really have a good way of predicting it because we don't have a specific output. Associate is another unsupervised model technique, and this is the one where, well, the people at Google and Amazon and elsewhere use this because they say, you know, Canode bought this driver. I bet he'd like to buy this putter. So when he goes into our website and clicks on driver and buys it, we're going to show him a picture of the latest putter and hope that he buys that too. Or if he bought a book about science fiction, we're going to show him a book about virtual reality or something. So again, there's no target here, but there's an association. They're trying to say, if you bought X, you might often buy Y. How do we build that? Well, we have a lot of people who bought milk and bread. We have other people who bought milk and beer. We have other people who bought bread and pretzels. And what the associate models do is go through and figure out the likelihoods, if you will, of people buying any two products out of that list. So again, machine learning. We'll get into all this stuff. You don't need to worry about it. What you need to do is just watch some of the videos. Now, there are walkthroughs on each of these. I'll give you the link in a minute. So let's say something very quickly about each of these. Classify. Remember I said this is a supervised learning technique. This is right out of the documentation. Extracts patterns. That's pretty much what most of them do, right? Extracting patterns is very useful because we're looking for a pattern. We're looking for people who have X, Y, and Z characteristics more often than not tend to commit fraud or tend to leave the company or tend not to return to school or whatever it is you're trying to predict, whatever the target is. Okay. Explain the value of the target column you choose. So you choose a target column and then you try various inputs and see how it works. The model can be used to predict a missing classification in the target column when the values of the other columns are known. So once you have a model, then somebody walks in and you say, tell me about X, Y, and Z. Oh, I think you're going to commit fraud. Oh, I think you're going to churn or leave the company. Oh, I think you're not going to make it in the graduate program. whatever you're trying to predict. So you specify which columns you use as inputs to predict the classification. Classification models work best. Again, I highlighted this. When you have a small number of distinct values to predict. If you're trying to predict whether a person will pass or fail or unknown or pay back a loan or not, or whether a transaction is fraudulent or not, again, we're only trying to predict 2, 3, 4, 5 things here. 4 or 5 values of the output variable. So it works best for that. That's a classification model. We have estimation models, which are more for continuous variables. Instead of trying to predict just a few things, we're trying to predict a number. Okay, we're trying to predict perhaps the likelihood that you will donate to the campaign to raise money for a new field house. Okay, again, extracts patterns, explains the numeric or date-time value of a target column. The other one explained the value of column. Estimation models work best if your data is within a reasonable range. Outliers should be removed. Again, we'll say more about that. There are some of these, and again, there are techniques under each of these kinds of models. So there are techniques. Segment, this is the one I mentioned. If you're trying to cluster your cases into groups or clusters or segments, they call the same thing, that share similar characteristics. So the software automatically says, you know, Canode is more like the senior citizens than he is the millennials. Okay, I'll put him in the senior citizens category. Okay, and maybe it'll cluster me by age or cluster. It'll figure out the best way to cluster things, and it'll figure out the best values to cluster on. But you won't be able to predict much. You'll just say, well, I got a group of people that are senior citizens that are all likely to buy golf equipment. I got another group of millennials that are likely to buy tennis rackets or something, and then you figure out what to sell. Segmentation models work best on numeric data or columns with a small number of distinct states. Again, same thing. Associate, there's your market basket. Product A implies product B. So if you buy a putter, it's likely you're going to buy golf balls. Okay, which means we'd want to put golf balls on the same page as the putter. Try to get you to do that. So the association, again, unsupervised because we don't have an output to predict, but it will still do useful work. These are still useful. These two are still very useful. And then, of course, forecasts, time series. Now here, if you have time series data, maybe you said, here's what happened in the market last week, the week before that, and the week before that. Here are the variables. Tell me what's going to happen in the market this week. So you've got time series value, and then there's several forecasting methods that are used there to try to predict what's going to happen. So those are really the key ones. Those are the key kinds of models. We'll talk about the details next time. Now, there are some, what I would consider to be great learning walkthroughs, because what it does is says, click here, try this, click here, try this. Now, when you do the walkthroughs, you can click and be done very quickly. You say, oh, yeah, I'm done. Yay, I did the walkthroughs like Canode told me. No, when you're doing those walkthroughs, you want to try to click on something, and then you want to say, what did I just do, and why did I do it? Because unless you understand what you did when you did the walkthrough, you're getting minimal value. It's not a race to see how fast you can get through the walkthroughs. It's something where you should spend some time trying to learn, what am I doing, okay? So there's walkthroughs for Insight Now. Remember, that's that really good one that basically gives you that key influencers. It'll walk you through the various pieces. Then there's some specific walkthroughs for the Insight Analytics to build models. Classification, association, segmentation, estimation, forecasting. I wouldn't spend too much time on the forecasting. That's usually the least valuable. But I certainly would look at classification and estimation first, and then the association and segmentation, the unsupervised models next. You're going to have the opportunity to build both kinds in this course. You're going to build at least one of each type. So not to worry. But these are great. They just rebuilt them entirely to go with version 4 or 4.5, and they're really quite nice. So they do a reasonable job of explaining what's going on, as well as telling you where to click. Additional sources. Okay, people always say, or they have said in the past, what are some additional things about prediction that would be useful to know? This is a really good example. It's a video on YouTube, walks you through the entire process, creating a model, very sophisticated model, by the way, for hospital-acquired infections. That's a biggie. That's one of the big uses of prediction. You want to be able to predict that so that you can avoid it. Take mitigation strategies to not have that happen, right? You don't want people readmitted because Medicare and Medicaid don't pay if you readmit someone within 30 days. And you don't want to have people getting infections while they're in the hospital. It's a big concern. So this is a really good walkthrough webinar-like thing. This is an article of how they worked with this Illinois, the state of Illinois, actually. It's either Indiana or Illinois. It might be Indiana. But they worked with the state to reduce preventable hospital readmissions. What I just said, if you're readmitted within 30 days, the hospital says, oops, we're not going to get any money out of this guy because Medicare says you should have treated him better the first time. Shouldn't be coming back within 30 days for the same illness. So this is really a good article. Then there's another demo of how they actually, and you can see this one's pretty current, May, last month, of how they are using Predixion, of course, this software, to predict, I'll say a little bit more about this in a minute, to predict maintenance breakdowns. One of my big mantras, and I've been pushing this mantra for probably 15 years, and it's finally coming true, was the mantra that says the old motto of if it ain't broke, don't fix it is going to change. To fix it before it breaks. It's a lot cheaper, a lot easier, a lot better, prevents a lot of catastrophes if you fix things before they break. And the real question is, how in the world would I know something's about to break? Well, until we start putting sensors in everything, it's hard to tell, isn't it? But once you have sensors in there collecting information, guess what you can do with all those sensor information? Well, they become inputs. And so once you have enough past data, let's just say you've got 15 sensors in your refrigerator. And, of course, occasionally the compressor breaks on a refrigerator, doesn't it? Well, you take all that past data and you say, oh, look, let me feed that to a predictive model. And it says, oh, when X, Y, Z, and Q and P are aligned a certain way, the compressor breaks in a half a day. Well, now when the sensors are out there collecting information real time and you get X, Y, Z, P, and Q aligned, it phones in and says, get somebody out here. We got a half a day before the compressor is going to break. May not be 100% accurate, but what if it's 3 or 4 times more accurate than just waiting until it breaks? Still worth it, right? So this is a really good demo. This was just last month. Want something more current? How about something this month? This is a really good webinar. If you have time to watch this, this is excellent. June of 2015, which I think is pretty current. So you might want to watch these things. Watch this, read this, watch this, watch this. It'll give you good background, good insights, good context for why prediction is on the move. Now, they are making a big push to be a prime candidate to be involved in building models from the Internet of Things. Okay? Again, we're going to put anywhere from 50 to 200 or more billion sensors in things. Sensors are getting dirt cheap, whether it's RFID chips or other kinds of sensors or point-of-sale sensors and everything. And those sensors keep collecting information and pushing it somewhere into the cloud, obviously. And something in the cloud collects that, feeds it to a database, and says, okay, let me see if I can build a predictive model from that. Okay, and of course you want to be able to do that on tablets, on smartphones. I saw a presentation, it's been at least 15 years ago, where they said we will eventually get to the point where we can predict many, many, many things, almost everything. Okay? If you can build a predictive model based on the sensors in your toaster that tell you when your toaster is about to catch on fire, you'd like to know that. Okay? So knowing everything about everything at all times is interesting, but being able to predict things before they become catastrophes is going to be even more valuable. And this Internet of Things is really hot right now. So they want to be one of the leaders in that. So I thought it was worth mentioning. This is from that webinar in May or June. This is the predictive maintenance example. I pulled a couple of screenshots out of the webinar because I thought it was terrific. They were using, this was one of their first forays into the Internet of Things, intervening to prevent, oil rig failure. See, that's one of the things where if you wait, if it ain't broke, don't fix it. It doesn't work, does it? If an oil rig goes down, it's a big deal. So if you could predict that an oil rig is getting close to failure and do something about that before it fails, that would be big. So here was the challenge. Large energy company, expensive oil rig companies, equipment failure means everybody's got to stop. Unnecessary maintenance takes equipment out of use, blah, blah, blah. Solution. They built a predictive model using sensor data and oil rig maintenance laws, created the answer in 3 weeks. Pretty impressive. Sensors on the oil rig components monitor pressure, temperature, vibration, blah, 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 just like sensors in your fridge, sensors in your toaster, sensors in your car. Thousands of scoring predictions are made per second. Field maintenance operations leverage analytics in real time. Key benefit, they were able to identify an oil rig failure 14 days, 2 weeks, before it was set to occur. That's big. Don't see many case studies like this that really have this kind of success to toot their horn about. Identifying an oil rig failure 2 weeks before it occurs and take corrective action. So how does the model know that? Well, it says, I've seen this before. I have a predictive model that says when I have X, Y, Z, Q, and P lined up a certain way, most of the time the oil rig is going to fail. And when it sees X, Y, Z, Q, and P lined up, it sort of raises its hand and says, beep, hey, we got 2 weeks over here. Somebody comes out and says, well, let's change the oil in it or put a new sensor in it or do something, fix it before it breaks. Pretty neat. Pretty neat. Again, some other successes. They've had successes in many fields. You can go read about those things. This, again, a lot of this came out of their webinar in May. So 2 months ago, I wasn't aware of all these things. I watched the webinar and said, wow, I'm even more impressed. You can see a lot of the things they're focusing on. Healthcare, obviously, fixing things, transportation, retail, marketing. Boom. Okay, so what are we going to do? Well, for week 5, it's clear what you're going to do. You're going to watch the videos, the tutorials. You're going to try walkthroughs. You're going to spend lots of time exploring. Have fun with it. Don't try to go and say, oh, I'm going to do my week 8 assignment in the next 2 days. No. The better thing to do is spend some exploratory time learning the software. You'll be much better served long run. You can come back and converge and build the models. You know, when I used to teach decision making, there's 3 stages. There's diverging, sharing, and converging, especially when you're doing decision making in groups. And what happens is, by and large, those of us, including myself, who are very task-oriented, don't spend enough time diverging. You got to diverge, brainstorm, get some ideas out there, try things, experiment, have fun, learn. Then you share what you've learned. You know, you share them with yourself because it's an individual assignment. And then you converge to your assignment. So as long as you don't skip spending maybe your 15 to 20 hours this week, you'll be fine. Okay, so that's what you're going to do. Build a few models. You can start thinking about what you're going to do in week 8 because you're going to build at least one supervised and one unsupervised model. One supervised, one unsupervised. That's the minimum. Okay, so what are we going to do next week? Well, we're going to talk about the models in a lot more depth, and we're going to talk about the accuracy charts because these are the little things that tell us which of the models is really winning the war. And you say, well, that should be easy. There should be just a number that comes out that says the model was 82% accurate or 68% accurate or 96% accurate. The answer to that is no, it's not that simple. We have multiple measures of accuracy. We have lift charts. We have LOCs. We have MS mean squared error terms. We have classification or confusion matrices. We have lots of things. And you'll see that it can be a different kind of measure to use in a different kind of problem depending on what it is you're trying to achieve. So we'll talk about that next week. So I won't come back and say a whole lot about prediction next week. I'll be focusing on these things. But certainly we will want to have some experience with that. And as questions, issues, insights, tips, whatever come up, post those in the discussion areas. Because, again, you may come across something that I have not seen before, thought of, and it's a great idea, a great tip on how to use a piece of the software. Remember, this is a new version that just came out in about April, while we're in the middle of last semester. So, you know, when you see an interesting insight or a tip or a question, post it somewhere in discussion so we can all see the answer and help each other figure out some of these things out if need be. Okay, last slide as always says, if you have a question right now that you need an answer to, feel free to ask it in the chat window. Anytime during the week, if you have a question that you think the answer would benefit all, put it in the Let Me Have Any Questions area. If it's something that pertains to just you or you'd rather not do that, you can email or phone me. I'd be glad to do my best to answer the questions. So this should be a really fun week. You're done with Decisions First for now. You finally got through the framing, which I know you probably thought you'd never hear the end of that, but let me tell you, it's going to come back, and it's extremely important to be able to do that. You'll be getting some feedback on how well you did and so forth. But we're going to move on now to the middle piece of the Davenport triad, which says, let's build some models. It's one thing to frame the problem, but you got to build the analytical model that sort of gives you the answer to the question. Okay? I don't see any questions showing up over there in the chat window. So what I'm going to do is, first of all, as always, I will stop sharing my screen. And the next thing I will do is stop the recording.